Welcome to Royal Math Podcast. Today, we're going to be looking at lesson 15-2, which is indirect measurements. And what we are going to do is we're going to apply properties of similar figures to determine missing links, and we are going to solve problems using similar figures. Now, what does it mean to have a similar figure? Well, similar figures are figures in which the lengths of the corresponding sides are in proportion and the corresponding angles are congruent. Okay, so what is congruent? Congruent is another way of saying equal to or exactly the same. Corresponding sides has to do with sides that belong with each other in different objects. So if I have two right triangles, in which I'm going to draw right here, if I have two right triangles, they're different sizes, but if they're similar, that means that their angle measurements are exactly the same. Angle measurements are congruent. Now the side lengths are proportional. That means if I have 5 here, I would have 10 here. If I have 15 here, I would have 30 here. Notice that each one is twice as big as the other one. So we have corresponding sides. Let's go into that a little bit more. Our corresponding sides, if we take this right angle right here, that is a point of reference. So we know that the long side that comes off of the 90-degree angle corresponds to the longer side that comes off the 90-degree angle on the bigger right triangle. Furthermore, we also know that the base, or the shorter end that comes off of the right angle, is also corresponding to the shorter end that comes off of the right angle on the larger triangle. Now, finding the missing links with indirect measurement. So in order to do this, what we have to do is first we have to know the height of a person. And by knowing the height, let's say it is 6 foot. So if we have a person that's 6 foot, then what we do is we go outside and we can find the measurement of a flagpole, a building, or anything of greater height that we can't measure directly because of its height. So we go out, we stand right next to whatever it is we want to measure, and we measure the shadow length of both the person that we know the height of or the object. You can use a meter stick or a yardstick or anything like that that you know the absolute measurement of. And then you also measure the object of the pole or building or whatever the object is that is too tall to measure. So let's say that we have a shadow length of 4 feet for the person. Now we measure the shadow length of the object, and let's say the shadow length of the object is 20 feet. All right, so we're going to set up a proportion, and of course our height here for the undetermined figure is x. That's what we're going to be solving for. So we put corresponding side over corresponding side. So we're going to start on the left, and we're going to start with the shadow length. So we're going to do shadow length of the pole, which is 20, followed by the shadow length of the person, which is 4 feet. Now we come over to the third fractional line in our proportion, and our height of the flagpole is x, and our height of the person is 6. Now all we do is we cross multiply. So 20 times 6 is 120. And that equals 4 times x, which is 4x. So now we are going to do inverse operation of coefficient. So x is being multiplied by 4, so we're going to divide both sides by 4. Numerator goes inside the house, so 120 goes inside the house. 4, or denominator, goes to the outside of the house. 4 goes into 12 3 times, evenly, and we zero out, add the 0 there, and we know that x equals 30. So without measuring it, we now know that this flagpole, due to its shadow length, is 30 feet long. Now, finding measurements through indirect measuring can be used for numerous applications. Chefs and cooks can alter the size of their recipes, either bigger or smaller. Mechanics, if they have to have additives to oil or anything they're doing, they can definitely adjust it. Construction workers might have to make a porch proportional to the building size or any other numerous applications, along with architects and any profession or hobby that uses measurements. Now let's take a look at one of the book pages, and if you'll notice here for question 1, we have triangle ABC, and that little tilde symbol, this symbol right here in the middle, means similar. So this says triangle ABC is similar to DEF. Now there's a couple different things before we get started that I want to go over to make sure everybody understands. If we look at the order in which the triangles are listed, the first letter corresponds to the first letter of the second triangle. So that means angle A corresponds to angle D. Angle B corresponds to angle E. And last but not least, angle C corresponds to angle F. So each one of those angles corresponds to each other. And the bottom sides, AC, correspond to FD. AB corresponds to DE, and BC corresponds to EF. Those are the angle and the relationships in which they live. All right, so let's go ahead and erase all that extra work. That way we can solve for the missing angle. So the first thing we want to do is we want to find a common ratio. So what we do is we take the corresponding sides in which we have both of them, and we write them down. So we're going to do 3 over 12, 3 over 12. And we have 4 over 16, 4 over 16. Now, what we need to do is we need to reduce those and see if they reduce to a common ratio or a common fraction. So 3 can go into 3 once, and 3 can go into 12 4 times. 4 can go into 4 once, and 4 can go into 16 4 times. So we have a common ratio of 1/4. The reason why we want to do that is, 1, to make sure they're proportional, and 2, working with smaller fractions or ratios when cross-multiplying is a lot easier than working with the original fractions. All right, so we're going to take all of the measurements, and we are going to rewrite a proportion up here, 1/4 equals. Now we must look for the side that is missing. And the side of 5 corresponds with the missing side, or missing side length of x. So we have 5 over x. So now we cross multiply. 4 times 5 is 20, and 1 times x is x. So we know that this missing side length is 20. Notice it was done exactly the same as finding the missing length of a flagpole or other figure. This has been Royal Math. Thank you, and have a good day.